We all just expect our data to be there when we need it, right? But here's the thing we don't always think about. The physical world is always trying to take that data away. I'm talking about hard drives, servers, network cards. Let's be real. All of it has an expiration date. So that brings up the big question for anyone running, well, anything. When a piece of hardware does fail, and believe me, it will, what's the plan? What's the automated system that keeps everything online without losing a single byte of data? Well, for ages, the answer looks something like this, the classic three-tier architecture. You had your servers doing the thinking, a whole separate network for storage, and these huge, expensive, proprietary storage boxes. I mean, it worked, sure, but it was just this super complex puzzle, a total headache to manage and really, really expensive. And all that complexity got people thinking, there's gotta be a better way, a simpler, smarter way. What if the real solution wasn't buying another pricey box, but was actually hiding in plain sight inside the servers you already own? And boom, that is the big idea behind vSAN. Instead of all that separate, complex hardware, vSAN is just intelligent software. It takes all the storage drives spread across your servers and turns them into one giant shared pool of resources. It's what we call a hyper-converged approach, and it gives you that same bulletproof protection, just with a design that's, well, a whole lot simpler. So how does software pull this off? How does it actually protect anything? Well, it all starts with you. You get to create the master plan for your data, telling vSAN exactly how you want it to survive when things go wrong. And really, the heart of that whole plan boils down to one super simple setting: failures to tolerate, or FTT. This is where you, the admin, get to call the shots. You decide just how indestructible your data needs to be. Can it survive one server going down? Maybe two. You make the call right here. And when I say simple, I really mean it. You're not digging into some crazy command line or scripting a complex storage array. Nope, you are literally just picking an option from a drop-down menu. You decide, hey, this data needs to tolerate one failure, or this stuff is critical, I need it to handle two failures. It's honestly that straightforward. Okay, so you've made your choice. You've set the policy. Now, vSAN takes over and executes your master plan. It takes your instructions and automatically figures out the smartest way to place your data across all the servers to meet your rules. Now, vSAN basically has two main tools in its toolbox for this job. First is mirroring, or RAID 1. Think of it just like a photocopy. You have your original, and you have a complete identical copy sitting on another server. Simple, fast. Then you've got the more clever method, erasure coding. This is more like a secret agent's code. It breaks your data into little pieces, adds some clever math, and spreads it out. That way, even if a piece goes missing, it can be perfectly rebuilt from what's left. And this is where that secret code method, erasure coding, it's absolutely brilliant. To handle two failures, the old photocopy method would need 3 times the storage space. But with RAID 6 erasure coding, you get the exact same protection, but it only costs you 1.5 times the space. That's a huge saving. And modern vSAN is so ridiculously fast now, it can do all this complex math without slowing things down at all. That's why it's pretty much the go-to method these days. All right, so protecting data is one thing. That's great. But what happens when a drive actually dies? How efficiently can the system recover? How fast does it get back to being fully protected? That's the real test, right? And this right here is why the new vSAN Express Storage Architecture, we call it ESA, is such a massive deal. Just look at the numbers. In the old way, a single drive failure could mean rebuilding a whopping 24 terabytes of data. With ESA, that same failure, it only impacts 4 terabytes. I mean, look at that. That is an 83% decrease in the amount of data the system has to move around. What does that mean for you? It means your system gets back to being fully protected way, way faster. Okay, now we get to my favorite part of this whole story. It's a little bit of a mind bender. It's this totally counterintuitive idea that as you add more servers, your setup actually gets safer, not more risky. Yeah, I know what you're thinking. That sounds completely backward, right? Your first thought is, wait a minute, more servers means more things that can break, more points of failure. How in the world does that make anything safer? Well, the magic is all in how vSAN places the data. See, vSAN is smart. It only spreads a piece of your data, an object, as it calls it, across the bare minimum number of servers it needs to follow your rules. So if your policy needs 6 hosts to be safe, it uses just those 6, even if there are 24 in the whole cluster. This means as the cluster gets bigger, the odds of a random failure hitting the specific servers holding your data gets smaller and smaller. And you can see it right here on this chart. The probability of an outage doesn't just go down, it absolutely plummets. Let's just zoom in on that for a second. In a big 24-host cluster, once your data is already protected against 2 failures, the odds of a third server failing and actually taking out that specific piece of data is just 0.18%. 0.18%. That is ridiculously low. It's the ultimate power of spreading out the risk. Okay, let's wrap this up. What does all this actually mean for you? What are the big takeaways here? First, your data protection is all about smart software now, not clunky, expensive hardware. Second, you are in the driver's seat with that one simple policy, failures to tolerate. Third, remember that modern vSAN is super efficient, using erasure coding to save you a ton of space. And finally, and this is the big one, don't forget that surprising twist, bigger vSAN clusters get more resilient, not more fragile. It totally flips the old rules on their head. You know, at the end of the day, this is about something much bigger than just storage. It's about software taking these incredibly complex hardware problems and just making them simple. It makes the whole system more efficient, more powerful, and surprisingly, way more resilient. And it really makes you wonder, right? If software can so elegantly solve the problem of hardware just failing, what's the next supposedly unsolvable problem it's going to make disappear next?